Before we go to Ed, I just want to ask if there's one or two very pressing questions or comments that anyone would like to make. Okay.
I have
Yes.
a quick question. The companies talk about they can use better materials and better chemicals, and have they been able to show that, or they even let you know what chemicals they're talking about, or ones they use?
Representative, all I know is that I've seen the same industry press releases that you have about so-called green chemicals, but that whenever we go to even propose to the Obama administration or to state regulators that they should ban the use of toxic chemicals, or even just ban the use of diesel, they fight tooth and nail against that proposal. So I think, to me, the proof is in the pudding. We haven't seen it.
There are a lot of comments I could make, but the one I would want to make, since it was the last thing you said, was on Massachusetts and the possibility of fracking here. I have an article from the Boston Globe from December, which first sentence is the possibility of Western Massachusetts may hold limited deposits of gas shales is catapulted to continue a contentious issue of fracking, which is essentially what you're saying. But then it says, geologists say it's unlikely that deposits will be extracted anytime soon because there is probably too small, scattered, and questionable quality. No companies have expressed interest in exploring gas shale, state officials say, and the type of wells needed to get to the gas are prohibited by the state. And then it has, in June, U.S. Geological Survey report assessed that 5 East Coast basins, including the Hartford Basin, have been determined to have 4 trillion cubic feet of natural gas. By comparison, the oil-rich Marcellus Shale Formation, which is the one that covers Pennsylvania and Ohio and some West Virginia, has 141 trillion cubic feet. So 4 cubic feet versus 141 trillion cubic feet. Then it's then geologists say that unlike the Marcellus Shale form, the Hartford Shale is thin and not in large unbroken plains, meaning it is not ripe for gas extraction. And Stephen McBee, Massachusetts state geologist, says a good portion of the basin is also overheated from volcanic activity, which means any gas or oil is probably gone. Now that's the article which covers the whole area, whole subject.
So your question is there really ever going to be fracking in Massachusetts? Yeah. So let me say a couple of things.
I think the other thing.
What?
Let's just spend a minute on this issue, and then we'll hear from Ed.
I think the quick answer to will there be fracking in light of all those questions are, number one, we totally dispute the notion that fracking is already made illegal by regulations. I can go into a long regulatory analysis. Totally disagree. Number two is that the industry is constantly evolving its techniques to be able to extract more and more problematic shale formations. Let me finish. Number three is that right now oil and gas prices are at an all-time low, so you're not going to see those investments now. But our view is that if gas prices rise, and we think they will because the industry is trying to do massive exports of natural gas, that you are going to see them investing in more marginal plays like Western Massachusetts. And finally, my last point is, if really there's unlikely to be any fracking in Massachusetts, then there really should be no controversy. Our legislature should just ban it right away and get it done with.
Okay, we may come back to that issue, but Ed, let's hear from you.
Okay. I've got a lot of questions too, but I'll wait for those. I'm a practicing lawyer. I do land use litigation, and I got interested in renewable energy and clean energy. And someone asked me earlier, why do I hang my hat in the Sierra Club? And the answer is pretty simple. Bloomberg did my due diligence for me. He gave him $50 million, and that's enough for me, so that's where I'm going ahead and putting my effort when I retire. So I didn't have far to look. Let me deal with some basic facts. 1 molecule of methane, 1 molecule, is, from a greenhouse gas standpoint, equal to 23 molecules of carbon dioxide. 23. Now, I know there's some scientists in this room, and they do this math in their head, but it'll become more specific a little later. If one converts all the coal plants in the world today, including China, India, to natural gas, and you assume a 2 to 3 to 3.5% increase in energy usage every year, and that's probably low for China and Africa, etc. Although you get a lower emission of mercury, sulfur dioxides, nitrous oxides, within a certain compounding effect, you'll be exactly where you are today, 10, 12, 15 years from now, from a carbon standpoint, and a greenhouse gas standpoint. That's assuming that you just cut the carbon content from combustion in half. But there are other factors that were adverted to. NOAA, National Oceanographic Administration, did a study in Colorado and said that the fugitive emission, those are things that gas escapes in the process, from natural gas exploration and piping is 9 to 11%. EPA, which you might have seen, cut that figure in half, but they had a different methodology of study. And the two, in many respects, are comparable. They said 4.5%. What does this mean? Okay. Let's take a coal plant that emits 10,000 molecules of CO2. It's more than that, but it's a very small coal plant. And convert that today to natural gas. Right away, you cut the emissions to 5,000 molecules. But if you assume that from the time you extract the natural gas, you pump for it, put it in the pipelines, and deliver it to the combustion chamber in the utility, there's natural gas leakage. All you need is about, from my calculations, 4.5% leakage to make that natural gas plant equivalent to the coal plant you just converted. That's because if you take methane, which is CH4, and you combust it with oxygen, and you need 4 molecules of oxygen, you get CO2, that's 2 molecules of oxygen, and you get 2 molecules of water. Now, water is a good byproduct. It doesn't happen with coal, but it does happen with methane. And it's one of the risks of putting a methane gas fireplace in your house. It raises the moisture, etc., and carries a smell with it, but that, maybe some of you are familiar with that. So, if you think about, so why is this so? Why is this so? It's because if you convert 10,000 molecules of CO2 to 5,000 molecules of CO2 by conversion to natural gas, and the ratio of 1 methane equals 23 CO2 molecules, 1 molecule of methane equals 23 CO2 molecules, you divide 50 by 23, and you just need 2.5 molecules of methane to equal the 50% or the 5,000 molecules, or 217 molecules of methane to equal the 5,000 molecules of CO2 you've reduced, reduction you've had from conversion to coal to gas. So my figures are not exact. I'm an engineer, I'm not a scientist, but looking at all I've done, we're talking about a leakage rate within 4, 5, 6%, which is within the ranges that both the EPA and NOAA have said occur in this natural gas process. Even worse, in Boston and Cambridge, there are 5 leaks for every mile of natural gas pipeline in the city. There's a legislation put before the House, before the General Court 2-3 years ago. It's still going on, trying to force the gas companies to clean up their act and shut off these leaks. Mr. Representative Smyson knows about this. You work with Phil Sago. Phil Sago is a very good colleague of mine. We work together on that. Another fact, what are the public policy issues, aside from the little ones I just talked about? Energy security. I think there's an argument that energy creates global alliances that have a tendency to preserve stability and peace. And energy independence, country to country, can maybe fracture some of those alliances. So where do we go? Australia is going to become energy dependent. When China goes ahead and mines its natural gas in Asia, in the Gobi Desert, etc., they're going to become more energy dependent. Europe can be energy dependent. Natural gas and shale gas is all over the world. So as we become energy dependent, what do? You create these ties again by trade, technology, and services. We replace the global energy trade by technology, trade, and services that every country depends on the other for those services.